So thanks so much, everyone, for joining in today's webinar. I see some familiar faces, or at least names, on the chat. So thanks for those who are making another appearance at one of our webinars. For those of you who don't know me, I'm Kat Massey. I'm the director of the Ambient Air Division here at Apex Instruments. In today's webinar, we're going to be discussing a case study related to odor detection at a landfill site using our multipollutant sensor system. So just a quick little background on Apex Instruments for those who might not be familiar. We were founded in the late 1980s and we are located in North Carolina. We're experts in manufacturing and selling air quality equipment, and we have traditionally focused on emission stack testing equipment, but we've branched out to include ambient air and fenceline monitoring applications. We also have custom trailers that we build out, and we offer different training sessions as well related to all things emission stack related. So within the Ambient Air Division, we have two different product lines. So we are the distributor for both of these product lines. We have our customizable multi-pollutant sensor system on the left, which is manufactured by Kunak and will be the topic of discussion today. And then we also offer a field deployable gas chromatograph for speciated detection of volatile organic compounds in near real time, and that product's manufactured by Omniscient. So for today's webinar, I'm going to, I'm not quite sure how many folks are super familiar with landfills. So I'm going to kick off today with a little bit of background context about emissions coming from landfills. Then I'll review the sensor technology a bit and then dive into the case study, and finally wrap up with sharing a couple more takeaways related to odor detection using our sensor systems. So what do we need to know about landfills as sources of emissions? Well, today I'll generally be referring to landfills that are municipal solid waste landfills. And these types of landfills are the third largest source of human-related methane emissions in the US. And many people also consider this to be a lost opportunity for capturing a significant potential energy source in methane. So landfill gas is comprised primarily, about 90% at least, of methane and carbon dioxide, while the remainder of this landfill gas is composed of nitrogen, oxygen, ammonia, sulfides, hydrogen, carbon monoxide, and various other gases like VOCs. In landfills, typically this landfill gas is produced when bacteria breaks down organic waste, and gas production increases typically with increasing temperatures and moisture content. So some of the impacts related to this is on communities living near landfills who are subject to a number of negative health effects. Could be related to respiratory problems, nausea, headaches when exposed to some of the gases that are produced at landfills. Additionally, landfills have been shown on occasion to pollute nearby waterways. We're going to talk about how they're a source of air pollution. Landfills, as I think many of us are familiar, can cause foul odors, and they can be a source of noise pollution. And all of this can impact the property values of neighboring communities and in general have pretty negative psychological impacts on the overall well-being and quality of life of folks who live near landfills. So this table here comprises some of the common compounds that are associated with landfill gases and their associated sources of organic material. I thought this was interesting to kind of get more into the root source of some of these, what's contributing to the landfill gases. And I'll also just comment here that following the webinar, we'll be sharing out these slides and we'll make a copy of the recording available to you all. So don't feel the need to take too rigorous of notes. So focusing in on methane and ammonia for a moment. So methane and ammonia, we know, are mostly produced from decomposing organic matter like food. One of the reasons why composting food waste is super important when possible. Methane is typically odorless, but humans can actually smell ammonia starting around 5 parts per million. Hydrogen sulfide is another common odor that's detected related to landfills. Hydrogen sulfide is often generated from kitchen waste, waste, and gypsum drywall board. As it decomposes, it releases H2S. And humans are actually extremely well adept at smelling and detecting H2S. We can smell concentrations as low as 0.5 parts per billion. And while concentrations at this low amount aren't necessarily harmful to human health, it's still quite an inconvenience to be smelling garbage consistently. And then other odorant we'll talk about is related to volatile organic compounds. VOC emissions from landfill sites could constitute as much as 10% of the total VOC emissions in the entire US. So it could be a pretty sizable percentage. We have different aromatic compounds in landfills that originate from petrochemicals like coal, tar, asphalt, and crude oil, often related to benzene. And then we have halogenated compounds that are primarily from chemical products like in disinfectants, pesticides, as well as degreasers. So pivoting quickly to talk a little bit about our multipollutant sensor system and how it's equipped to detect different odors at landfills. So just dialing back a bit more, our multipollutant air quality system is designed to fill a void between reference grade instruments and low-cost air quality sensors. So our products, really, we pride ourselves on having highly accurate data. We have the unique capability of being able to detect several pollutants simultaneously. They're cost-effective and allow for improved, better spatial resolution of your site that you're testing. And we're consistently seeking out additional verifications, evaluations, and certifications on the performance of these units. So our product offering is composed of 2 different sensor systems. So the one on the far left is the Apex Air Pro. This multi-pollutant sensor system can simultaneously detect up to 5 gases in addition to particulate matter. Then we have the Apex Air Lite, which is a more compact version, slightly less expensive, that can simultaneously detect 2 gases in addition to particulate matter. And these units are really unique because of our smart gas cartridge system. These are the sensors that are designed to be plug and play, so you can just swap out the cartridges depending on your project's needs. And all of this is tied into our Apex Air Cloud platform, where you can visualize data, manage the operation of your systems, and do a lot more. So in thinking about how to select a solution that's appropriate for your needs, you first want to identify which pollutants you're trying to detect. That'll inform which sensors you would be purchasing. Depending on the number of pollutants you're trying to simultaneously detect, you'll decide to either go with the Air Pro or the Air Lite. And we also offer a number of additional probes and power supply and communication options. So you have the opportunity to add in a wind sensor or a noise sensor directly to the system. And then all of this data is displayed on the cloud software, where you can do different visualizations and check the operation and performance of your units. And then we also have different data tools like an API if you want to send this data somewhere else. So here's a list of the different gas sensors that are currently available, along with some of the meteorological sensors on the far right. And I'll just highlight that there's a few more sensors that are slated to be released early next year. And to give you a sense of what these units look like up close, so on the top right, you have a little video showing the plug and play capability of these gas sensors. So they just slot right in, you push them in, they connect automatically to the unit. They each have a PC board embedded in them, which allows them to talk to the cloud platform. And then we also have 4 additional connectors at the bottom of this unit where you can add in additional sensors. Here's a closer up view of the air light unit. And I'll also highlight that both of these units have embedded temperature, humidity, dew point, and pressure sensors. They're equipped to be outdoors with a solar shield. And they have a little LED display located directly on the unit so you can quickly see and check in on performance and connections. Here's a couple screenshots from the cloud software platform. So we have the ability to generate heat maps, pollution hotspots, and leak detection when you combine an anemometer with our system. You also can quickly generate distribution plots looking at particulate matter size. You can do multi-parametric analyses comparing different sensors, and you can generate customized reports that are automatically and periodically sent out to a designated listserv. All right, so moving into the case study on landfills. So wanted to highlight some general challenges facing landfills and what was related specifically to this case study. So like many other industrial sites, landfills are interested in identifying polluting processes related to their activities and detecting fugitive emissions. This particular landfill site wanted to understand the environmental impacts related to their operations, and then also assess the effectiveness of certain mitigation strategies. So here's an aerial view of the particular site. This landfill is located in Portugal and is in a region that's next to a biogas plant, a highway, a slaughterhouse, as well as a couple gas stations. So there's multiple near neighbors that could be contributing to different pollutants. In this particular case, not so many neighbors like residential neighbors, so didn't have quite the level of noise or odor complaints as some facilities, but they were wanting to better understand the impacts of their operation. So they decided to use the Air Pro system with the five gas cartridge system, and equipped it with methane, ammonia, hydrogen sulfide, nitrogen dioxide, total volatile organic compound sensor, and particulate matter, along with an anemometer. And then this system was positioned at the neighboring biogas plant. So by positioning air quality stations along the fence line, combined with an anemometer, you can generate polar plots to determine the source of the pollution. So here, evaluating methane, the methane sensor, you can see quite clearly that the biogas plant is primarily responsible for methane emissions here. Looking at the methane data a different way using the cloud platform, you can quickly and easily plot data over time to look for patterns and trends in pollution data. So here we can see that methane was spiking over a couple of days in the nighttime and early morning hours. So acquiring this type of information allowed the management team to make different operational decisions in the attempt of mitigating the methane emissions. Looking at data related to the ammonia sensor, again, generated a polar plot, able to tell that both the landfill and the biogas plant are contributing to ammonia pollution in the area. And then looking at the H2S sensor, it's pretty clear that the landfill is the guilty culprit for the H2S emissions. Here we have the NO2 sensor data, and you can see that most of the NO2 pollution is coming from the nearby highway. And then for PM10, we can see that the landfill is contributing the majority of this larger particulate matter pollution. And I'll just say that for the Air Pro system, this larger system, we break down particulate matter into PM1, 2.5, 4, and 10, along with total suspended particulate matter. So you can see a pretty granulated view of what type of particulates you're dealing with. And then finally, looking at data generated from the total VOC sensor, you can see that the landfill is certainly emitting some VOCs, but we also have a hot spot off to the right, which we expect is related to the gas stations that are located nearby. So findings from this case study, the landfill was able to identify the different sources of fugitive emissions to better understand how their operations impacted emissions in the region. By having this type of information, they were able to devise different mitigation strategies. So for instance, at a landfill, they could determine when and where to deposit waste, perhaps depending on wind patterns. They could also select the appropriate cover material depending on the weather and temperature parameters, and then they could make more real-time informed decisions based on having all of this data combined into one site via the cloud. All right, so I wanted to share just a couple other comments and considerations related to evaluating odor with our multipollutant sensor system. So diving into hydrogen sulfide a little bit more, we have run some studies comparing the hydrogen sulfide sensor to hydrogen sulfide analyzers and have shown that these sensors have a very high precision with a correlation coefficient R² value of 0.77 and a mean absolute error of 6.9 parts per billion. I'll also say here that the H2S sensor is responsive. It generates a signal for for methyl mercaptans. And the methyl mercaptans are also registered by the total VOC sensors. So when you compare our H2S sensor data to an H2S analyzer, our H2S sensor might be reading slightly higher because it could be detecting these methyl mercaptans. So this slide shows some data, just a quick set of data from this comparison of an H2S analyzer with our H2S sensor. And you can see in the zoomed in region, we're generating signal related to these methyl mercaptans that the H2S analyzer is not picking up on. So that's the majority of the reason for the R² value being 0.77. This data was collected at a wastewater treatment plant, which we know had methyl mercaptans, and there was an alarm threshold set at 20 parts per billion. And after evaluating the performance of this sensor, the H2S sensor, that was also, there was also an H2S analyzer present at this site, we were able to evaluate the true positive rate of this alarm being signaled versus the false positive rate. So almost 90% of the time, the H2S sensor was accurately measuring 20 parts per billion or above, whereas only 16% of the time there was a false positive signal, which again was likely related to the methyl mercaptans being present in the area. So one way to account for this is to operate the H2S sensors with a total VOC sensor. So here we're comparing the H2S analyzer with the H2S sensor and the total VOC sensor. And you can see in the green that there's instances where we're not generating any signal, but both of the Kunex sensors are picking up on the signal for methyl mercaptans. So when you operate both of these sensors together, you can at times adjust the signal to reduce or offset the signal based on your understanding that there's methyl mercaptans present, not actually H2S. I also wanted to highlight that we offer a number of different sensors based on the target measurement range and target application. So we have two different H2S sensors with different measurement ranges listed here. We actually have three different ammonia sensors. Two of the ammonia sensors are designed for more of a leak detection mode, whereas one of the ammonia sensors can be operated where there's a continuous higher concentration of ammonia present. And then we have two different volatile organic compound sensors with different measurement ranges listed there. And we are also about to release some new methane sensors in the early part of next year that have an expected measurement range of from around 2 to 300 parts per million. So as you're probably thinking, landfills aren't the only smelly place that you might want to conduct some fence line monitoring. So we've also seen these units have a lot of success being used near wastewater treatment plants, at different pulp and paper manufacturing or processing sites, also at compost management and manure management sites, as well as at fertilizer plants. So if any of those perhaps smelly facilities are within your domain, you might consider using these systems. And I wanted to just wrap everything up by comparing some of the higher level performance value benefits of the Apex Air products. So again, we really pride ourselves on having highly accurate data compared to reference stations. So we're seeing accuracy between 80 and 85% when compared to reference stations. We're a very versatile, highly customizable product. So we have the ability to detect these numerous pollutants simultaneously, and we have good accuracy for detecting both fine and coarse particles. So these products are well designed for all types of different industrial ambient air monitoring applications, as well as different research or consultancy oriented work. We didn't talk too much about the power supply options in this presentation, but many people like to power these units using a solar panel, and we have an embedded internal battery that allows for the sensor system to operate for around 20 days without any charge because they're very low power. And then if you missed our last webinar, we talked a lot about different calibration and quality assurance measures related to these units. But one of the more unique capabilities of our sensor system is that we have a detachable gas hood that can be added to the system to do in-field real-time calibration work. So I hope you learned something new about odor detection today using these sensor systems. I'll leave this slide up with my contact information, and then I would like to welcome you guys to ask some questions with the remainder of our time.